Hello everyone, this is John with Siptopia.org. Welcome to the Oracle/Acme Packet Session Border Controller Simplified Configuration Series Part 3. In this tutorial, we will be covering layer 4 to layer 6 in the 7-layer OSI model. We will start with a concept some people really struggle with, the realms. By using a certain analogy, just like in other tutorials we had, we are hoping to easily digest the realm concept. Then we will configure our SIP interfaces, followed by steering pools and session agents. General election in United States is a few months away. Let's use an analogy to describe the realms concept, but stay with this trend and talk about the political food chain in United States. President is at the top, responsible for all states. At the top of each state is the governor. Governor knows everything that goes out to the president from the state. Governor also knows everything that comes down from the president to the state. Each state has mayors who talk to the governor in order to reach the president. Communication between any two states, A and B, go through president. We have a quite straightforward workflow in this setup. At the end of the day, mayors of state A talk to the governor of state A, governor of state A talks to the president, and the president talks to the governor of state B, who in return talks to the mayors of state B. Now, let's replace the words president with SBC core, state with realm, governor with SIP interface, and mayors with session agents and see how this setup looks like. SBC core is where the call routing decisions take place. It is like the president of a country if the country is an SBC. Therefore, if United States is the SBC in our analogy, then the president is the SBC core. SBC core is responsible for routing calls for all realms. It's just like the president being responsible for all states of United States. According to this analogy, states are realms in an SBC. Let's continue to make more sense out of this. A state has multiple entities. At the top of each state is the governor. This entity is responsible for the communication between the state and the president. Similarly, in a realm, SIP interface is the interface, as the name implies, to the SBC core. All calls from this realm to the SBC core go through this SIP interface, and all calls from SBC core to this realm go over this interface. Keep in mind, the governor himself or herself belongs to the state. Therefore, a SIP interface belongs to the respective realm it is in. Mayors are entities below the governor, and they talk to the governor to reach the president. Similarly, session agents are SIP entities like SIP proxies, PBXs, SBCs, and so on, and they talk to the local SIP interface to reach the SBC core. Naturally, just like the governor, the mayors belong to the respective state. Therefore, session agents also belong to the respective realm, just like the SIP interface that belongs to that realm. Now, the workflow from the previous slide turns into a call flow. Session agents of realm A talk to the SIP interface of realm A. SIP interface of realm A talks to the SBC core. And after the SBC core makes the routing decision, SBC core talks to the SIP interface of realm B, and SIP interface of realm B finally talks to the session agents of realm B. Please take a screenshot of this and the previous slide to compare the two. After you completely understand the analogy and how it applies to the SPC, the realm concept will be a walk in the park. Since we have 4 physical interfaces, 4 network interfaces, let's configure 4 realms. Well, in our analogy, states refer to the realms, so let's name our 4 realms: Alaska, California, New York, and Texas. Alright, we logged into our SPC, and now let's go ahead and add our realms. To enter the realms, we are going to follow this path. Do a select. Note that there is nothing there. Let's hit the question mark and see how many entries are there in a realm configuration. That's about 30. That's a lot of entries. In this case, for us to enter the realm configurations, we are literally just going to use 2 entries. That's number 1. California realm is about to be configured. Keep in mind, these are coming from the network interfaces are coming from the previous tutorial. And finally, the realm Texas is configured. Alright, just like in any other configuration change, don't forget to save and activate once you made these changes. A quick show run to make sure our realms are there will let us finalize this section. Alright, let's move on. From the previous tutorials, we know that it is safe to follow the 7-layer OSI model to configure the session border controllers. We started with the configuration of 4 physical interfaces, and then we configured the network interface for each physical interface. Now we are moving up in the 7-layer OSI model and adding a SIP interface for each network interface. Therefore, each network media port on the SPC will now have a physical interface, a network interface, and a SIP interface. In our analogy, states were realms, governors were SIP interfaces. Just like how a governor belongs to a state, SIP interfaces we are about to configure will belong to our realms that we just configured, which we named Alaska, California, New York, and Texas. Each realm gets a SIP interface. Let's go. Alright folks, just like we discussed, each realm will get a SIP interface. So we are going to configure 4 SIP interfaces, one for Alaska, one for California, one for New York, and one for Texas realms. So let's go to SIP interface level. Just for the sake of this tutorial and the 90% rule, let's hit the question mark. Wow, there is a lot of entries here. There is a lot of entries. And the 90% rule tells us that 90% of these will be left with the default values. So we can simply proceed with whatever you see here. So let's go and start with the SIP interface for the realm Alaska. Now we are going to go to the SIP port level and then copy paste these entries. We are done with configuring the SIP port. That's why we hit the done command. But after the exit, we are still configuring the SIP interface, so this requires another done. Alright, so let's see, Alaska is already there. Let's move on to the SIP interface for California. We are going to go down to SIP port level, do a select, and copy paste. Done. exit, another done. Do a select, make sure the two are there. And folks, of course, these IP addresses came from the previous tutorial where we configured the network interfaces. Now it's time for the SIP interface for New York. Let's go to SIP ports level and simply copy paste what we have here. Done, exit, done. Another select to make sure all three of them are there, and move on to the final SIP interface, the interface that belongs to realm Texas. Do a select, go ahead, copy paste this entry, do a done, exit, done, and voila, we have all our SIP interfaces configured, one for each realm. So let's go ahead and save and activate our configuration. Do not pay much attention to the error here. That's because we haven't configured the SIP config object yet, which is going to take place in the next tutorial. So let's do a show run just to make sure our SIP interfaces are there. Very cool. Alright. Boom, we are done. Let's move on. Next, we are looking at the steering pools. Mayors talk to the governor in order to reach the president. So, how do the mayors talk to the governors? The governor has a number of phones in the office within a certain area code. For example, if a mayor in Alaska is talking to the governor of Alaska, the caller ID of the governor will start with 907. If you consider the possibilities for the next digit, the caller ID would be between 9070 and 9079. Same principle applies to California, New York, and Texas. Pretty straightforward, right? Now, let's apply this analogy to the SPC terms. Session agents in our Alaska realm we configured earlier talk to the SIP interface of the Alaska realm to reach the SPC core for call routing. We know what IP address and transport protocol / port the SIP interface of Alaska realm uses for signaling. We just configured it. While the signaling is being established, the offer-answer mechanism in session initiation protocol determines which IP address and port entities will use. For more information about session initiation protocol and offer/answer mechanism, please watch the RFC 3261 Simplified tutorial series. Well, if the SIP interface is going to use an IP address and a port for media, we have to configure them. While the IP address could simply be the same IP address the SIP interface uses for signaling, the one that we just configured, the ports have to be defined and they cannot overlap with port ranges used by other SIP interfaces. Remember, we have 4 of them. In other words, the port ranges for each SIP interface have to be unique. It's exactly like the area code in a state that the governor uses. The analogy is quite similar. Alright, let's configure our steering pools and use the area codes we mentioned in our analogy to put more emphasis on the similarities. Therefore, the Alaska realm / SIP interface will use the port range 90702 9079, whereas California realm / SIP interface will use the port range 9160 to 9169, New York port range 5180 to 5189, and finally Texas port range 5120 to 5129. Alright folks, let's go ahead and configure our steering pools for each realm. In order to start configuring the steering pools, we go to Media Manager and under Steering Pool section. So let's go ahead and simply copy paste these entries just like we did in previous configurations. California, port range, let's do a select just to make sure they both are there. Let's add New York, done, select, and finally the port range to use in the realm Texas. So do not ever forget to go back to the enabled level and save and activate your changes. Alright, let's move on to the next section. We mentioned session agents several times already and associated them with the mayors in our analogy. Let's take a closer look to understand the concept better. Keep in mind, ordinary people are not all considered mayors. Ordinary people talk to the local mayors. Similarly, do not think that every SIP endpoint, whether it's a phone or video unit, etc., are session agents. Generally, SIP proxies, PBXs, SBCs, and other large central SIP entities that connect to our SBCs are considered session agents. Of course, that is if we configure them as session agents. A SIP proxy in a network doesn't automatically become a session agent. To keep it simple, think of session agents as SIP proxies. Again, to keep it simple, think of session agents as SIP proxies recognized by the SBC in the configuration. Endpoint use SIP proxies to talk to the SIP interface of the SBC. As an example, let's say an internal phone in a network is configured to use a SIP proxy that is considered a session agent in the SBC. We know from previous slides that the session agents as well as the SIP interfaces belong to realms. Therefore, let's say this phone's call reached a SIP proxy, a session agent, in realm Texas. The session agents in realm Texas are configured to use the SIP interface in realm Texas. Therefore, the SIP proxy now sends the call to the respective SIP interface of the SBC. Since the session agent is recognized by the SBC, SBC sends the call up to the SBC core for call routing. Let's say this call was to a phone in another network reachable via the Alaska realm. In this case, SBC core would send the call to the SIP interface that belongs to the Alaska realm, which in return would send the call to a SIP proxy / session agent that again belongs to the realm Alaska. From the SIP proxy, the call is now delivered to the respective destination phone. Visiting our analogy, this is quite like an ordinary person in Texas wanting to reach another person in Alaska via a letter. In our political scenario, these ordinary people have to go through certain hops to reach each other. Therefore, the person in Texas gives the letter to one of the mayors who belong to the state of Texas. That mayor gives it to the governor of Texas. Governor of Texas now gives this letter to the president, who in return gives it to the governor of Alaska towards its destination. Governor of Alaska now sends this to the mayor that is local to the destination person, and the mayor delivers the letter to that person. Alright folks, we are back into the SBC, and now let's assume we have two SIP proxies in each realm and proceed. So in order to start configuring the session agents, we go under session agents level, do a select, and then simply copy paste this information. Before I do that, just for the sake of this tutorial, let's hit another question mark and see the countless entries that make up a session agent. Naturally, 90% of these entries could be left with the default values. So without wasting any more time, let's go ahead and proceed with entering our SIP proxies. Now, I'm going to give you guys a tip here. If you have a long configuration like this that you are going to enter, well, you may want to, instead of copying, you may want to cut instead of copy, so that when you are done and get back here, you are not confused with where you left. So let's cut this one. Done. Select. Both of the Alaska SIP proxies are there. You see, instead of trying to figure out where I am, I'm just doing a cut, come back and configure the next at the top of the list. Done. Select. The next one is a New York SIP proxy. Done. Select. The next one here is the other New York SIP proxy. And now we move on to the SIP proxies in the realm Texas. You see, this is quite easier than going through all these entries to figure out where you left configuring. By removing the one that you just put in, it makes it easier for you to see what's next. So, as you can see, we entered 2 SIP proxies for each realm. And let's go ahead and save our configuration. Remember, the error you are seeing here is because the SIP config object is not configured yet, which we will do in the next tutorial. In this tutorial, we focused on layer 4 to layer 6 of the 7-layer OSI model. Specifically, we talked about realms, SIP interfaces, steering pools, session agents, and how they are linked to each other. We hope that the analogies used throughout the tutorial were helpful in understanding the concepts better. If you have any questions or comments about this tutorial, please let us know.